In previous examples, we've looked at how to take a derivative using the chain rule, the product rule, the quotient rule, and now the chain rule once. But what happens when you have a function inside another function inside another function? What I mean by this is sometimes you have the composition of multiple functions. So in example 5, we're going to look at taking the derivative of g of t, which is equal to tangent of 5 minus sine of 2t. So if I label these, I can actually break these down into 3 different functions. I see that tangent is my first function. I have 5 minus sine of something, and that's my second function. And I have 2t, which is my third function. So just like in previous examples, I'm going to take the derivative of each in order to set this up to make it easier when I do apply that chain rule. So we have f of t is equal to tangent of t. So f prime of t is then secant squared of t. I have h of t is equal to 5 minus sine of t. So h prime of t is then negative cosine of t. And then I have L of t is equal to 2t. So L prime of t is then just 2. So now what I'm going to want to do is go ahead and take the derivative of my original function. So I get g prime of t is equal to, and so I like to start with the outside and work my way in. You are allowed to do it the other way, which is called the inside out method. It's completely up to you. So I start with my most outside function, which is tangent. And so the derivative of tangent then is secant squared. And then I place the inside piece back. So I get 5 minus sine of 2t. And then I notice that there's an inside piece, so I multiply by the derivative of the inside piece. So I get this is secant squared of 5 minus sine of 2t times, and the derivative of this is negative cosine of 2t, and then times the derivative of 2t, because I have another function inside of that derivative. So I'm left with secant squared of 5 minus sine of 2t times a negative cosine of 2t, and the derivative of 2t is just 2. And then what you want to do is go ahead and write it in the correct order. And what I mean by correct order is just get your coefficients to the front. So we get that this is negative 2 cosine of 2t times secant squared of 5 minus sine of 2t. So now on your own, I want you to try to take the derivative of 1 plus sine cubed of 2x and the whole thing squared by using the chain rule. So one hint that I'm going to give you for this problem is when writing powers of trig functions, like y is equal to sine cubed of x, always rewrite the function like y is equal to sine of x and then the whole thing cubed. All right, let's give it a shot. So I'm going to write y is equal to 1 plus sine of 2x, the whole thing cubed, and then that whole thing squared. So I notice that my first outside function is going to be this square. So I get f of x is equal to x squared. So f prime of x is then 2x. My next big piece is right here. So I get g of x is equal to 1 plus x cubed. So g prime of x is then 3x squared. And I get my next piece is right here. So h of x is equal to sine of x. So h prime of x is then cosine of x. And I have one more piece on the inside, which is just that last 2x. So L of x is equal to 2x, and L prime of x is equal to just 2. So the pattern here is I keep taking the derivative of the inside pieces until I'm not left with any inside pieces. So if we do this right, it should just be this times this times this times this. Of course, substituting in the inside pieces for those x's. So I get that y prime is equal to the big outside piece, so 2 times 1 plus sine of 2x cubed times the derivative of that inside piece. So I get y prime is equal to 2, 1 plus sine cubed of 2x times, and the derivative of this is 3, and then my inside piece. So sine of 2x, the whole thing squared, times the derivative of that inside piece. So y prime is equal to 2, 1 plus sine cubed of 2x times 3 sine squared of 2x times, and then the derivative of sine of 2x is cosine of 2x times the derivative of that last inside piece. So y prime is 2, 1 plus sine cubed of 2x times 3 sine squared of 2x times cosine of 2x times 2. And now all we have to do is combine our like terms. So I've got some coefficients running around. So y prime is 2 times 3 times 2, which is 12. And then I like to actually, with trig functions, go from the lowest power to the highest power. So 12 cosine of 2x times sine squared of 2x times 1 plus sine cubed of 2x. And that's how you use the repeated chain rule when you have to do it a bunch of times.